Hello guys, welcome back. So here we have another question on network theory from GATE 2016. The circuit below is excited by a sinusoidal source. The value of R in ohms for which the admittance of the circuit becomes a pure conductance at all frequencies is dash. So this is the circuit they have given. So there is a L in series with R and a capacitor in series with R, and these two are in parallel. And they have given terms like admittance and pure conductance. So what does it mean? So we know that we have impedance Z, and this I can write it as real and imaginary part. So the real part is called as resistance and the imaginary part is called as your reactance, and admittance is nothing but your inverse of your impedance, and this also I can write it as two part, a real and imaginary part. So the real part is called as your conductance and the imaginary part is called as your susceptance. So now what they are telling, the circuit becomes pure conductance at all frequencies. So irrespective of omega, your Y should be purely conductance, which means that your B should be equal to 0, which also means that for your impedance, it is a purely resistive thing and your X should be equal to 0. The reactance should be 0. So this is the condition. We can take any one of them and try to find the value of R. So now if I have to write in terms of impedance, so this I can write as, let's say for now, I take it as 1 by j omega c and this is j omega L. So this impedance is 1 by j omega c plus R and this is j omega L plus R. So the total or the equivalent impedance is 1 by j omega c plus R in parallel with j omega L plus R. So this is equal to 1 by j omega c plus R into j omega L plus R divided by 1 by j omega c plus R plus j omega L plus R. So this is equal to L by C plus R into j omega L plus 1 by j omega c plus R square divided by 2R plus j omega L plus 1 by j omega c. So this j omega L plus 1 by j omega c, I can write it as some j into some x. So I'm not meaning this x with the reactance which we already discussed. This is some term x, or I'll also put it as a small x. So then what will z equivalence become? So it is L by C plus R square into jxr divided by 2r plus jx. So now I want to make this jx term and I want to find r such that this is 0. So what I'll do, first I'll just convert everything to the numerator. So for that I will multiply by 2r minus jx by 2r plus minus jx. So then what does it become? So this will become 2r into L by C plus R square plus j into x into 2r square minus jx into L by C plus R square and minus jx into this. So it will be plus x square r divided by, this will be nothing but a square plus b square. So it is 4r square plus x square. So if you see, x itself is real, right? So then what I will have, I need to make the imaginary term of this go to 0. So the imaginary term of this is nothing but x into 2r square minus jx into L by C plus R square. So this I want to be 0. So x anyway goes away, j also goes away. So it is 2r square minus L by C minus R square is equal to 0. So your R square is equal to L by C. So your R is equal to root of L by C. So this is the value of R for which at all frequencies your impedance is only as a resistive part and your admittance has only a conductive part. Okay, so your C is 100 micro and L is 0.02. So 0.02 by 100 micro. So your R is root of, this is 2 into 10 power minus 2 by 10 power minus 4. So this is root of 2 into 10 power 2. So it is root 2 into 10. So this is 1.414 into 10, which is equal to 14.14 ohms. So for this value of R, this equivalent circuit is purely conductive, okay, purely conductance. So your answer is 14.14.